Hi everyone. So we will learn about what sharding or partitioning is in this video. I will start off slow and I'll explain what it really means. When do we need it? Do we need it in all cases or not? And so let's get right into it. The kind of question that I really want to solve in this video is this: like, what will you do if your application actually scales off, right? If you hit a large number of users, what kind of impact will it have on your application, and how will we scale it, basically? So I have a small diagram that basically shows how a normal web app really works, right? So you have your users, you kind of hit the edge network, basically the CDN or your load balancer. You can hit the Cloudflare. Usually that's what almost all of the internet uses. Then it forwards those requests to your origin servers, your API gateway or Nginx proxies or whatever. That internally transfers the requests to your services, whatever pods they are running in. And finally, it hits your master DBs, right? And the masters, whatever changes you write in your master DB, that is replicated in all the replicas. And all the reads are done through replicas, and all the writes go to your master DB, right? This is a fairly straightforward architecture about how systems really work. Now, this works well, okay? Now I want to kind of try to understand what will start failing when the number of users kind of increase, right? When the number of API requests increase, right? So Cloudflare would not really get impacted because it really works at a global scale. Neither would your API gateway, and not would your services. All your write queries will actually hit your master DB. Okay. So with time, this master DB is going to start getting clogged if there are lots of writes. Let's say there are millions of rows in your DB, and there are thousands of concurrent connections, and all of them are writing in your master DB, right? So what will really happen is if you have indexed your DB, the writes are going to slow down dramatically, because once your DB grows large in size, the index also keeps growing with it, right? So the input out is going to get maxed out, and the throughput is going to be through the roof, and it just is, your DB is just going to stall. Okay. So once your DB stalls, once there are a lot of requests that are waiting, your services will start to get impacted, because there will be a lot of queries inside these services that are waiting to get executed. I mean, they are waiting for responses from your database, right? So, and this will basically just cause a lot of problem to the user. If the queries keep on continuing, your DB can simply fail, you know. So in this case, there are a lot of solutions to this problem. The simplest one is to basically just upgrade this machine, right? Whatever master DB you are running, it is inside a virtual machine of some sort, right? It could have a RAM of 2 GB. You can basically increase it to 4 GB, 16, 32, 64, right? That's the simplest solution that you have. But this cannot keep on going forever. You cannot have infinite RAM, right? What else can you do in this case? So this is what is called vertical scaling. Okay. Vertical scaling can help you up till a certain point, but after that you cannot keep on adding infinite computation to a machine. To solve this problem, what we really do is not vertical scaling, we do horizontal scaling. We break our master database into several small master DBs. Okay. And that really helps us increase the throughput through the system and reduce the amount of pressure on a single node, on a single VM. Okay. And this is the entire concept of partitioning or sharding. Is basically when you have your database and you break it down into different small databases, basically. So I have a diagram, the exact above diagram. What we will have is, instead of a single master, we will have smaller DBs, right? That will contain the data, and we basically say that we have sharded the master in this case. We also have replicas, because usually what happens is that whenever you have a sharded master, you also shard the replicas, right? But you don't really have to worry about this. I only want you to focus on these three masters, okay? I'll give an example. So let's say your table has 1 million rows, okay, and what you really want to do is that okay, over here what was happening is, let's say you have a table of users, right, a million users. Someone comes in, adds another user, you will add another row to that table of million users, right? This is bad because of course your index is going to get your index is already pretty huge, and what if a lot of requests come in, 1,000 requests per second, your table is going to kind of grow large in size. So in this case, what we do is, for example, let's say a million rows, right? So the first 0 to 1 to 300,000, we put that in, let's say this shard. This is called a shard, okay? Let's say we put 0 to 300k in this shard. We put the 300 to 600 in this shard, and 600 to a million in this shard, okay? And we kind of keep on repeating this process. So a million to a million, 3,000 or 300,000 will go in this shard again, and we kind of keep repeating this, okay? This is basically what sharding is, and yeah, so this is basically what sharding is, okay? Now what is the benefit of this? Of course, you can see that if you had one machine, right, over here, and you basically have 3 machines over here, what this means is that you have thrice the throughput that your system can kind of capture. You also can technically store 3 times the storage of whatever this master could store, because you're using 3 times the machines in that way. And none of these machines are going to get bombarded with all the requests. How will that happen? I'll show that to you. Okay, so I'm going to discuss about how some small strategies about how sharding really works, okay? Okay, let's look at this. This is a pretty simple example. Let's say we have a master DB that contains the users, right? We're talking about a key value pair, okay? Let's say the key is the name of the person, the value is their information, right? So for me, the key is going to be RN, and the information is going to be all the stats about myself, right? Let's assume that we have this DB, and we stored all of this in one single table. Now the table is exploded. We have a lot of users. We have a billion users, right? What we should do in this case, again, is kind of break our DB into 3 small DBs, okay? So we have one DB, let's say this one DB. We store only the names that start with A or E, like in this range, in this DB. For F2O, we store in this. For B2Z, we store in this, okay? This will instantly reduce the pressure on the one single DB that we had. And this is called sharding by key ranges, okay? Now this is good, but it also has some downfalls. Let's talk about what's good in this, okay? These range, when you shard by ranges, that actually speeds up the range queries that you have, right? So let's say that these were sharded based on some sort of number, right? Some sort of number, roll number or whatever, right? You could easily run a query like this: select star where user ID between 1.2 and 1.4, right? You would know instantly where these users live before you even ran the query. You don't even have to go to all the shards to see where the users are. So let's say that these users were in this shard. You could go over here, run the query directly. If you had an index, even better. That would basically give you the answer ultra fast, okay? If there was no index and no shard, you would basically have to query the entire DBs, your entire one monolith DB, okay? That's the good part. Now the bad part is, well, what if you have a lot of users whose name starts with A, right? So A is a pretty common alphabet, and a lot of people's name starts from A, right? In that case, it could very well happen that you're getting 10k requests per second on this shard. You're only getting 1k requests per second on this shard, and 500 requests per second on this shard, because very less people have their names starting from the alphabet Z. In this case, you kind of removed the whole purpose of sharding, because in the end you kind of broke your DB down into 3 DBs, and even then one of your DBs is getting all of the load, right? That's not pretty good. So that is one of the problem with these key ranges shard. Key ranged, how if that is how you basically shard your DB. Okay, let's look at a way to kind of go away from this problem. For that, what we will do is we will actually use hashing. Okay, so let's say that there's a user, he runs a query get user ID is 45. Okay, now what we do is we pass this 45 number into a hash function. Okay, that will generate another random number. Now this number is completely random. Okay, and we know that this hash function, the range of this hash function is 0 to 15,000, for example. Okay, in this case, so 45, the ID 45 got assigned to a random number 4562. Okay, and we have sharded our database in the way that, well, 0 to 5k are going to live on shard A, 5k to 10k are going to live on shard B, and so on with shard 3. Okay, now 4562 is between 0 and 5k, so that is directly going to shard the first shard. Okay, so this user's query will not even hit these two shards. It will hit this shard and the user will get their answer. Okay, now why is this better? How does this really solve this problem that we saw above, the hotspot one, right? It's a pretty simple explanation for that. So my name is Aryan, right? And some other's name is, let's say, Abhinav. Okay, now Aryan and Abhinav's hash is going to be completely different, right? I might get the hash as 4562. Abhinav might get the hash as 7734, right? Abhinav's data would get stored in this shard and my data would get stored in this shard. Really solves the problem pretty well in this case. Okay, but the downside of this is should be pretty apparent, that you can't really run these efficient range based queries, right? Over here we could really say select star where your data is between 1.2 million and 1.4. You knew that your data was living in this shard, but right now there is no such thing like that, right? Even if, so let's say over here your ID was 1.2 and 1.4, all of them lived in the same shard. Right now every single number or between in this range is going to have a different hash, right? Every number will get randomly distributed across all these three shards, and that will basically kill the kind of good speed that we got from these select queries. Okay, so that is a downside of sharding by these keys. Okay, that is the first thing. The second thing is, how do you really decide this? So are you going to shard from 0 to 5k, 5k to 10k? Like, who is deciding this number? Why is it 5k only? Why is it not 0 to 3k? Also, so on and so forth, right? That is also an issue that you can kind of think about in this case. We also, in this case, to kind of make it even better, in one scenario is to actually use this thing called hash mod n. Okay, where n is the number of basically DBs you have, the nodes you have, right? Let's look at this example only. You have number 45, so you pass that into a function, your hash function, you get 4562. When you have 4562, you take a mod of it with n, the number of total shards that you have in this case, right? That is 3. So you get a number 2 over here. Now when you take a percentage, when you take the mod of it with the number n, that basically guarantees that this number is going to stay between 0 and n minus 1, right? In this case, this will always stay between 0 and 3, I mean. So it can be 0, 1 or 2. So when you get a value from here, you can basically put that that user's information in this shard. Okay, you don't have to do these computations. That 0 to 5k is going to live here and so on and so forth. So 45 went to shard 2, so it's 0, 1, 2. So 45 kind of stays here. If there was another number and basically it said that its mod was 0, we could basically store that number over here. This is better than these range based kind of partitioning or sharding, in the way that you don't really have to kind of figure out what these ranges are. Okay, but the problem over here is that what happens if you add another node, right? Now you only have 3 nodes over here. What if you add another kind of DB? or if you take out a db, right, that is completely going to wreck this function, right? So you have 4562, right? Let's say I add 4 more dbs to this, so I have 7 more dbs. I have a seven number of total shards. So in that case, what will happen over here is going to be 4562, and to get which shard the database lives on, we will have to take a mod of it with 7. This is going to be some other number other than 2, right? But that is wrong, right? So in this case, you will have to move all of your data from the second shard to whatever shard you get from here, and that is going to be a big problem, right? So these hash based indexes work. Hash mode n works very well, but it kind of fails terribly when you want to change the number of shards that you have, right? When you want to add or take off some of these shards. To handle this now, to actually handle this hash mod n thing, we have something called I forgot the name of that. I think it's called consistent hashing. Yeah, it's actually called consistent hashing, and that is something that I will be explaining in the next video. So this is basically about it as an introduction to what sharding is. Why do we need it? You really only need sharding when your write queries kind of start slowing down in your main database, right? When you see that your IO is getting maxed out, your RAM is really you are at like 98% usage of your RAM. You don't really need to shard your DB just when you're starting out. There's no point of that. Postgres is pretty good. It's pretty versatile. It can handle like a lot of transactions, a lot of concurrent writes to the DB. But you only should shard your DB once you can see that no matter what you do, no matter how much power you give to a single machine, it's just not it's still very slow. That's the only time you should actually shard your DB.